Hello, everybody. My name is James. I'm at Brock University. I'm one of the technical staff for SHARCNet. I'm going to be presenting today some of the tools that I've been using to manage data that I have on SHARCNet systems. The main interest of this webinar is, although SHARCNet provides a bunch of compute, there's a bit of a curve in terms of getting data there and being able to manage it. Not to mention that typically whenever people move over to HPC resources like SHARCNet, the scale of your research can grow dramatically, and then there are all kinds of boundaries in terms of managing all the data and temporary files, etc. So what we're going to go over today is basically the file systems at SHARCNet, what their properties are, and then go over some strategies that I've been using to keep track of data, to help optimize what's going on at SHARCNet, and just to keep me organized and sort of allow the scale of research to grow. So as a general overview, I'm going to get started with a slide presentation. And that's going to start off just going over the SHARCNet file systems and the properties of the file systems here at SHARCNet. Then I'm going to go over some basic command line tools for file management. I'm using a Linux computer, and we're going to talk about Linux commands to basically transfer files, to control access, etc. And I'll just briefly go over those. Most of them are basic Linux commands that we use to manage data. I'm going to go over a bit of data transfer avenues and talk about the data transfer node at SHARCNet, basically a system that's specifically used for transferring data. And I'll also give a little bit of a talk on the Globus transfer system available through Compute Canada, where you can access DTN. Another thing that we can do to help manage and sort of interact or stay tuned with data files on the cluster is to use some of the visualization tools that are available. So whenever we're working with data now on an HPC resource, rather than having everything locally, we have it in several places. And there might be a lot of temporary files that you don't necessarily want to transfer back and forth all the time. So being able to go into the actual compute area and use some tools to just visualize temporary files can be very valuable just in terms of contributing to the load on managing data. So I'll go over a couple of those tools. Now, another easy way of sort of easing the burden on transferring from local files to remote files and your compute resources is by mounting those file systems to your local computer. And then a few benefits come from that. So I'll be going over a few ways of just mounting the local drives onto your local computer, and then looking at ways of visualizing there and comparing directories. And then I'll also do just a brief look at other clients and cloud resources. So particularly if you're working on a Windows computer, you'll want some clients even just to use the secure shell SSH. So I'll just kind of mention a few of those. And then just kind of to realize that there's options for using cloud resources. What you have at SHARCNet is access to storage facilities, and those can be integrated into some cloud resources that are available. And then we'll go into just the online documentation. So after going over the slide presentation, I'll go to the SHARCNet website and look at some of the resources that are there that really, where there's detail and updated information on everything that we're going over. The section on how to organize my files, using the storage, analyzing I/O performance, which we'll just go over briefly in terms of how to manage data in the actual compute. And then just look at some of the remote graphical connection pages. And then after that, we'll go into a demonstration. So I'll just go onto the SHARCNet clusters and do a few things. Probably look at quota and adding it to the bash RC. Do a demonstration of file transfer on the Globus. And then visualizing temporary files on the development nodes. And then I'll also demonstrate using sshfs, which is a way to mount remote drives onto a local computer, and then use Meld software to compare directories. And while that's mounted, then just use other local software to edit files or review files. So at the bottom of all this are really, we have file systems that have different uses at SHARCNet. And those file systems are defined by their properties. You can imagine how hard it gets to manage data on your local computer, let alone a space where there are many, many users doing large-scale analysis. So what we've tried to do at SHARCNet is design file systems that have specific properties to optimize certain uses for the storage. So one of the properties is the access. So there's unified access. That is, regardless of what system you log into, for example, the Orca system or the Kraken system, what you'll see in a unified access file system is that the same files are there regardless of where you log in. There are also per cluster access points. So these are unique files on each system. For example, if you log into Hound and go to a per cluster access system, then you'll see different files there than, say, logging into Orca. There are also per node access points. Now, this is unique files on each node. So not only within a specific system like Orca, but Orc 123 will have different files in Orc 124. Another property is the backup. So on remote clients in the file systems, sometimes you'll have backups and sometimes you won't. And the backups can take several different forms. So we have a file system that is backed up. And in general, what this means is that one version of each file is stored for the previous 5 working days. And then beyond that, one for each 4 previous weeks, and one version per month before that. Now, it's very important to know that not all the systems are backed up. In fact, there's only one system that's backed up. And this should really be considered seriously. So another property is that in order to manage the amount of use and the scale of the data that's handled on SHARCNet systems is sort of integrating quotas into these different file systems so that they're encouraged to be used in specific ways. So quotas can take the form of time. Basically, files on these systems can have a time limit. And the outcome of a time limit is basically these files get auto-deleted. So different file systems may have different time quotas, and at the end of that time, those files would get deleted. Quota can also take the form of a size. So in terms of the number of gigs or terabytes. And the size quotas can come in 2 different forms. A hard quota, basically, once that space is filled, you'll end up with write errors. So a hard quota in terms of size on a file system basically defines the amount of space that you have available. Once that space is reached, then no more files can be written and you get write errors. There are also soft quotas in terms of size. Now this means that you can keep writing to that file space. You won't get write errors. But once you pass a certain point, account constraints will be implemented onto your account, restricting certain processes that you are otherwise have access to. And we'll go over the specifics of this whenever we look at the exact configuration of the file systems. Another form of a quota is the number of files. So the file systems that are used in Compute can be affected by the number of files within directories. And to encourage fewer large files rather than many tiny files, constraints have been implemented in terms of a quota on the number of files. So this is also a soft quota. That is, once you exceed 1 million on any file system, account constraints come into play. So the files can be put there, but once they're there for a certain amount of time over the quota, constraints will be placed on the account that will affect being able to submit jobs or jobs in queue being submitted. And really what we're talking about today is in order to best manage the amount of data that you're using for compute and storage on these systems, how do you handle the files? So there's basically two things you can do. There's file transferring, which can take on several different interfaces, either the basic Linux commands at the command line, or different clients for transferring files, mounting files, and then using your local software to do it. Other than transferring files, there's also archiving and compressing. So this is the ability to take many files and collapse them into a single file, and then still being able to access those. And we'll take a quick look at the tar and dar options for doing this. So really, the SHARCNet file systems are listed here with their values for the different properties. So a very commonly used file system is home. This is the file system that when you log into a system, you're directed to your home directory. Now, its access is unified, which means that regardless of which system you log into, the files in your home directory are going to be the same. This is the file system that's backed up, like we mentioned before. And the size available is currently being upgraded to 10 gigs. And the quota on this size is a hard limit. That is, once you exceed this amount of space, you basically can't write anymore. There won't be constraints placed on your account because you actually can't go over this amount. And in terms of the time quota, there is no quota on the system. Another commonly used system is the work system. So the access to work is unified as well. So if you're working on files in one system and you want to transfer to another system, if you're working from the work directory system, you don't have to transfer files. You can just keep working from the same location. The system is not backed up, and it does have a size quota, but it's larger at 1 terabyte currently. And importantly, this quota is a soft quota at 1 terabyte. Now, the work systems typically used during compute. Now, having a soft quota on this means that if compute is happening and you are generating large files and many files, if during that computation you exceed your quota, you won't end up getting any write errors. Now, the soft quotas are basically checked at midnight every day. If at midnight one day it sees, the quota check sees that you're over your limit, you'll be placed on an over quota group, and then after 3 days, if you're still in that state, the constraints will start to be implemented on your account. Now this is a very important property to keep an eye on if you're using very large data sets and going from work. But with the soft quota, your jobs won't terminate. You won't get errors, but you have to keep an eye on it, or else you'll lose the capacity to submit jobs if you ignore the over quota state. And then the same thing in terms of the quota on time, there's none. The Scratch folder is local to the compute. It's also, the access is now per cluster. So this means that this is really sort of like using a local drive on the compute nodes, where depending on what system you log into, you'll have a specific set of files that is not unified across the systems. There's also no backup on this. It's typically used for compute. And one of the key properties that makes this one different is that there's no limit on the size. So this is a good place to do very large sort of data processing. Now, to compensate for the lack of a size quota, a time quota was placed on this system. So basically, you can put as much data as you want in there, but it's important that these are temporary files, that you keep this sort of fresh, current, active data, and that nothing is kept there long term. So the Scratch system is sort of defined by that, the trade-off between the size quota and the time quota. Now, sort of moving beyond the example in Scratch, there's also the temp file system. The temp file system is really for even more temporary files. The access is actually per node. So you have to go directly to a specific node where compute was happening to find those exact files. There's no backup, and there's no size quota. But this has a very short time quota in 2 days. So this is really for very temporary files that are being generated while you're doing computation. And for the quota on times, there's auto deletion in place. So for example, the scratch, after 2 months, on the Sunday, the files get deleted, and you'll get an email warning you if you have files that are set to be deleted on that Sunday, and then you'll have the opportunity to manage them before they get deleted. And once they're deleted, they're actually deleted. This is not a backed up drive, so it's important to keep track of those spaces. In terms of the temp, it's very important to keep track of it, that you aren't using temp for any sort of, even output files. These are really just temporary during compute. You can't depend on these files still being there between jobs. They'll always remain there while a job is running, but as soon as the job is finished, you can't depend on it still being there. And then finally, different from the others is the archive system. The archive system has access that's unified, so regardless of what system you log into, you'll always see the same data. There is no backup of the archive, and really the defining property is the quota. There is no size quota, no time quota. This is really for sort of the long-term storage of idle data, we'll call it. So it's not data that you're currently actively using, and it's not available to any compute in this system. This is really just a place to keep your data, to transfer it, for example, whenever you're going back and forth between scratch. So no quota on size or time in the archive. It's also not backed up, so treat that importantly. Really, the purpose of these is defined by, their properties. The home, because it has no time quota, it's backed up, its access is unified. You can use it for source and small configuration files. So you don't have a whole lot of space here, but it's backed up, it's secure, and it's long-term. Work is for active data. Whenever you're working on a project, if it fits inside of a terabyte, this is a good place to keep it. If you go, because the access is unified, you can move across systems and still have access to all of the same data without transferring it around. And if you did need more data than 1 terabyte inside of work, you can request an exception. Scratch is really for temporary files, and these are local to the compute node, so the performance is very good. But it's expected that if you have very large amounts of data, this is a good place to have it for the compute. It gets good performance, but it's also a temporary place where we don't want to keep this filled or have too many files in there to affect performance of compute. So this is an important one to be able to manage actively and to see what's there. Of course, temp is for very temporary files. These are really files that you will not actually look at outside of the compute. So these are files that are being generated and read by the actual procedures that are running as jobs, but isn't a good place for outputting files, as you can't depend on it to be there after you're done, and you'd have to go find it on the specific nodes where the compute happened. So these are really just internal to the compute. And then archive, clearly because it has no quota in terms of size or time, is a great place for long-term storage, and it's unified, so moving data to archive and back to the more sort of compute purposed systems is very convenient. So now I'll get into some basic command line tools for transferring data and for managing data, different things that you might want to do with the data. So there's a command called quota. Basically, this is a very useful command because it tells you how much space you're currently using. If I log into a system and type quota, this is an example of the output that I get, the standard output for quota. It tells me the system, it tells me the limit that I have, and then basically where I am at in terms of the number of files and the size the space that I'm using. If you are doing work that stays close to your limits, where you might start getting affected by any of these constraints, whether it be write errors or account changes, it's useful to put quota in your bash rc command, and it will basically just tell you what your quota is every time you log in. And we can demonstrate that a bit later. But if you are using a lot of large data, it's important to keep a track of the quota command. So SCP is secure copying. You can use SCP -R in this example to copy a local folder to a remote place. So this is, a typical general Linux command that's used to copy from a local space to a remote space. rsync is a very powerful tool for doing similar work more quickly, and rather than just copying, can synchronize. So it knows what files are already there and versioned. So this is a more efficient way of transferring the data from the command line. Now, rather than moving data around, if it's packing files, so if you want to take many small files and package them into a single file, you can archive it into a pack using tar, which is the tape archive. And here's just a basic example of packing a file. And then once you pack it, you can unpack it with a very similar command with the tar. Now, DAR is another example of this. It has a whole bunch of other options. In particular, you can build differential split archives, meaning that if you build an archive where you have many files put into one archive, and then you do a whole bunch more work, you have more files there, you can now generate a new DAR archive with the first one referenced. So it will only put the new things in this new one, also tracking what's been deleted. Other benefits of DAR over tar is being able to access files within DAR archives is much quicker, as there's basically a table of contents where it doesn't have to scan the entire thing. So specific things can be extracted, even during a job running, where you can, access a DAR archive, specific things, bring it to Temp, and then work on them, and then write them back. So if archiving is useful for any part of your research, and you're using tar, it's definitely worth checking out DAR. And then here's an example of unpacking it. So you can unpack specific things to a set location. Now, aside from moving data around and compressing or archiving data, there's also controlling the file access. So if you're working with collaborators, and for example, you have data in your archive that you'd like to share with a user or give them access, rather than having to copy it over to their space and really duplicating it in the total space, what you can do is you can share access. So set the file access list, setfacl. You can set the permission. So for example, here I have setfacl, and then recursively modify for a specific user. I'm going to give Stefan write or read access to my folder. Now if I do that, and then I use getFacl, I can see that for that folder, the user, Stefan, now has read access. So rather than having to copy it across user whenever you're sharing outside of a group, you can set these properties for an entire group. You can just set permissions. Now this can be very valuable in collaborations rather than copying files over. This is also very useful in terms of doing support. If you have someone who's trying to help you solve a problem, sometimes it can be very useful to just give them access to your files so they can look at them in your environment. So some of the data transfer avenues, typically what's done by default is either I'm on my local computer and I'll use SCP to transfer a file that I have here or a directory to a local address where I enter, a specific system, let's say Orca or Hound. But recently there's been the data transfer node. So you log into the data transfer node just like you'd log into Orca or Hound or Kraken or whatever. But the data transfer node doesn't have access to compute. What it has are properties that are optimized for data transfers. So it is dtn.sharcnet.ca as opposed to, say, orca.sharcnet.ca. Basically, it sees the internet in most SHARCNet file systems. There are a couple scratch systems that it doesn't see, but you can see all of the unified systems and several of the scratch systems as well from the data transfer node. And importantly, it has no CPU time limit on processes. So whenever you're transferring very large amounts of data, this is really the place to do it, because you won't run into any timing limitations on the transfer process. The data transfer node is also valuable in terms of working with your site's ITS. If your site is able to optimize a specific route to get high-speed transfers, this is the place that you would want to optimize. For example, here at Brock, we've optimized it so that any researcher on site who is transferring to DTN is sharing the maximum research bandwidth out of the university. And this simplifies it because it's just the one address at SHARCNet. Now, another good thing with having this sort of central transferring node is that other resources can sort of use this as a way of transferring to SHARCNet. So the Globus implementation for Compute Canada CA is a way of logging in online and doing fast, secure transfers. And you can build the Globus Connect Personal, which makes your local computer accessible on the Globus interface. And then you can just use this as an online platform for transferring data. And it has this nice, basically click on the right arrow to copy over, click on the left arrow to copy over type interface. We can try and demonstrate this a bit later. So, and then beyond transferring files and turning files, what's often useful in terms of file management is rather than bringing files back to your local machine to visualize them, you can log into machines remotely that will give you tools where you can explore those files. For example, even just opening a text editor to look at temporary log files that might be on the cluster that you don't want to have to bother managing and bringing down. But even looking at figures of data that are over there, for example, using Octave and Gnuplot. So a couple of the systems have development nodes. And a development node is basically somewhere where you can go that isn't being used by the scheduler, and it gives you access to the same compute resources and software as the submitted jobs that are scheduled and running, and you can log into them with visualization capacity so that you can open figure windows, etc. And we do this basically with the -Y option whenever you're logging in using SSH. So here's an example where I'm logging into Kraken with the option, and then going to the Kraken devl1. And then from here, I can load software and use it to visualize files that are there on the cluster. And being able to do this efficiently gets rid of a lot of the problems with having to transfer data back locally whenever I want to visualize it. Oftentimes, even with temporary files that, once they're checked, don't need to stay anywhere. Besides the development nodes, there are also visualization systems, and you can access these from the portal if you go to the systems page and look at the visualization system. And basically these blue windows basically just link you right in and start up a computer. And then you can just use it as a desktop to start software and to go to your data. And here's a visual example where you just start a desktop and you have applications available. And this sort of visualization system is sort of an important development that's going through rapid development right now. And then the simplest way to be able to transfer files is really to mount remote drives to your local machine. For example, if you're used to file explorers that you have on your local computer, ideally what you could do is you could just mount folders within the data transfer node onto your local computer and then just treat it as though it's a local drive and transfer files and compare directories that way. So one way that I've been doing this is using the sshfs mount. And this can be done from the command line, which is useful for running it from other programs. So I can mount with this example saying sshfs and then the remote location and then basically the path that I want to place it. And then from there you can actually compare directories using things like Meld. So Meld is, I think it was initially for comparing text files, looking at differences between copies of a file, but it can also do full directories. And in fact, it can do 3 directories at a time. But it can't deal with remote paths. So in this case, where you actually mount a remote path using sshfs, you can now use Meld to compare your local directory to even multiple remote directories. So in this command example, I say Meld, the local path, and then the mount path, where I've mounted a remote drive. And then here's just a brief example where you see 3 complex paths side by side, where on the left is the local version of it. In the middle is actually the work file system, where there's sort of current active files. And then all the way on the right, I have the archive system. And this is where I would want to put all of my long-term data. So there'll be different files in different places, but this is a quick way to compare them. And we'll see if we can do an example of this in a little while. And then it's easy to unmount using fuser mount U, and then you just unmount the system and you're back to normal. Another thing that's very straightforward is the SFTP. And in Linux file browsers, all you have to do is Control-L, and then enter the DTN and what you want to look at, and this mounts it to your local drive, and then it's just a mounted drive. Very easy to use, and then you can use all of your local file management tools to just deal with the remote path. And then just in passing, because we have access to these remote paths, it's good to think about is, these now different clients and cloud resources can be integrated with these big secure data resources that you have at SHARCNet. So things like OwnCloud and cFile and FileZilla could all be used with these systems to sort of manage your data and keep track of them. And this is something that I haven't been exploring too much, but I'm interested in looking to in the future as a way of efficiently being able to keep track of data and to handle the data. Now, I'm mostly working with Windows computer and different tools that are available there. If you're on a Windows computer, you'll need clients. So even just the SSH client, one that I use quite a bit on Windows computers is the Bitvice, and there's a Tunlier. So this will give you a terminal with an SSH login, as well as a data transfer client where you have your local path and your remote path, and you can just copy and paste across it. Moba Xterm is a very popular one as well. And then in terms of what we were doing, we were talking about a couple of minutes ago on Linux computers with SSHFS, there's also a Win SSHFS, which is a client for building SSHFS mounts on Windows computers. So that's it for the slides. Now let's move on to the brief sort of overview of the online documentation before I do any demos. So going to SHARCNet, of course, this is where all the documentation is kept. If we go to the FAQ, the knowledge base, one of the main things that you can see right away is that 3.8 is how do I organize my files. This is very valuable. You'll see all of the things that we've talked about before. And although, these systems and their properties are modified to keep up with what the demand is on the systems, this presentation will eventually be out of date. But these pages will be kept up to date with what the systems actually offer. And this really goes over everything. So, what the different systems are, what their properties are, what you should use, what it means to be backed up, and how to handle file permissions. So all the things that we talked about, you can look at the actual documentation as it is up to date on these pages. Then there's using the storage. So what storage is available. Here we go over the finer details of all this. Understanding, running the quota, and what all the details about how the quota works is all listed in here in terms of the difference between a hard and a soft quota and what the effects will be on your ability to run jobs. And also requesting exemptions and best practices. Of course, watch your quota. Now, this presentation is mostly about just managing data that is output files and input files to running. But there's also another level, which perhaps there'll be another webinar about eventually, and that's how the actual compute jobs are managing input and output. And there is a page on analyzing the I/O performance here. And this can be important in terms of determining whether there are too many files on a system and if the actual input-output of a job is running slowly, how you should best manage, if your job is creating too many tiny files, if it's creating very large ASCII files, we can help with converting those to binary files that are far more efficient, or converting many small files into larger files. So managing this I/O is really about how to optimize the actual running of jobs while you're doing it. And then, of course, you can get information on remote graphical connections. So here we have a page describing the options that are available for logging into systems remotely, and then using software on those systems to then explore the data rather than transferring them back locally. And all the clients that are available for doing this, as well as all kinds of instructions. Now, I guess what we can do is just from there, so keep track of the documentation online. This is where it'll always be up to date. And then what we can do is actually do some demonstrations here of using the system. So here I am on my local computer, and what I'll do is I will SSH over to Kraken. And then I'll just type in quota. So you type in quota, and then what it does is it tells you what's available. This is a good thing to keep track of. Now, I'm currently in my home directory, and there's this bash rc, and then what I can do is actually, I'll just open this. and I will insert quota here. Now, if you're typically running close to your quota, and you're always constantly trying to manage it, it can be useful to just enter this into your bash RC. And then this way, whenever you log in next, as you log in, you will just get your quota right away with everything. So just keep it out of the foreground. Why not? Now, another thing we can demonstrate is if we go online here, this is now, let me zoom in on this a little bit. This is now the globus.computecanada.ca file transfer. And basically what this provides is, two interfaces where you have endpoints and the paths, and then you can transfer between this. So this gives very fast and efficient secure transfers between endpoints that are available among the Compute Canada consortia. Now, this also includes being able to add your local computer. So if you click on this Get Globus Connect Personal, it brings you to an interface where you can define your local computer and install the software necessary to basically put your current local computer in as an endpoint. So if you go through this interface, then what you can do is go to the Globus and then just run this Globus Connect Personal. So what Globus Connect Personal does is it starts you with the capacity to be transferring files to Globus from your local computer. So this keeps it all secure and whatever. So I'm currently connected. And now what I'll do is in here as an endpoint, I will just enter this, and then I can see here I am. And then this is now my local drive. And then over here, what I'll do is I'll choose another endpoint, that is the Compute Canada. And if I go down here, I'll find SHARCNet DTN1. So now what I have is my local, my home directory access through DTN. And then what I can do is I can basically just select a file, and then this will become active, and I can transfer it over back and forth like this. So this is a nice, efficient way of transferring data back and forth, and it has endpoints at all the Compute Canada resources. Now, as an example of logging into a system and accessing files, I'll do this quickly. Let's say I want to access some files that I have in work. I'll see if that's up. SSH. Sorry. And the important thing is to add the Y option, which will give me the ability to do visual interfacing, SSHY. Cedar at kraken.sharcnet.ca. Okay, that shows my quota. Now, from here, I'm just going to go into a development node. So log in here and then do Kraken. I'll go into Kraken 6. I believe there are 8 development nodes on Kraken. Okay, so now that I'm in a development node, I can check what's free. So this is important to see what's being used here. Get top. Tell me I'm really the only one using this one. And then what you can do is you can just load modules. So I'm going to unload module unload until module load. So for a lot of the work that I do typically involves Matlab. And what I can do is, rather than trying to run Matlab on the clusters, I can actually do most of the visualization with something called Octave. So I'm just going to open this, open Octave. So now I'm running Octave. And this is entirely, I'm within the SHARCNet compute area, running a development node. And then what I can do are just, all the great things that I would do locally, like figure, surf, and say 10 by 10. And then this will actually bring up a figure. And then I can manipulate this figure and work with it just like I was on my local computer. Now, if I were to go to basically where I had temporary files that were currently in compute, I could actually explore those files from here while they're computing, and then I wouldn't have to bring them down if I just wanted to check a couple figures for the properties in those files. So I'm going to log out of here. Right. I got to quit out of Octave first. And then log out. Log out is the hardest one. Okay. Now, right. The other, a very easy way of now doing visualization is if you go to, this is now, if I go to Systems from the portal and then go down to Visualization Systems, it's very easy to just click on one of these, enter my username, and then my password, and this will log me into a system that's now on the cluster where I can access my files. And I already have Octave open here, and then I can do the exact same thing that I just did before, where I plot these, and then I can interact with the data. Let's do another thing where what I want to do is now just mount a file using the SSH and then run Meld. So what I'm going to do is I'm going to go to an external drive that I have and then go away into this research P14 and then project. Okay, so what I can do now, I'm in this folder and I have places where I can sort of, I can mount a remote archive. So what I'm going to do is I'm going to say sshfs, and then what I want to mount is jtjard at dtn sharcnet.ca /archive group projects Ruler B14. These are terribly long. Net project. Of course. And then the place that I want to put it is remote archive. Okay, so what that's done now is it has actually mounted my remote path to the local, and then I can just run Meld and say I want to compare the analysis folder to the remote archive analysis folder. And then this should actually bring it up. So what I have here now is a Meld instance where on the left here I have my local computer with an entire study's worth of data that I have, comparing it to what I have currently on the archive at SHARCNet. So what I can do now is I can compare what I have. If it's now time to, back up these raw files, I can simply click to copyright. But other things is that if I'm making changes to certain files, for example, in my support files and miscellaneous, I have a bunch of different text files. If I just click on them, it will show me the content of the two of them, and then we can actually compare and keep up to date within the files. So the current version of Meld that's available through the software tools with Ubuntu 14 has the capacity of just comparing files superficially. That is, some of these files are rather large, and if it had to check them byte by byte, it would take forever. But this really just compares whether files exist in one place or the other. And then for smaller files, you can just double-click on them, and they'll show you the actual contents of them compared. So I think that's all that I want to go over. Once things are mounted, you can even open any software locally, and then you can look at those. Meld is just really the one example of a local software that we opened, and then was able to compare the contents of local and remote files. And that is all that I have for today.